Welcome everyone to our webinar today titled Demolition Waste, brought to you by Ecologiq and ARRB. My name is Isabella and I'll be moderating the session today. Next slide, please. We plan to go for 60 minutes with time for questions at the end. And we'd love to have your input throughout the presentation. So you see here on the slide how to send your questions through. Now we are also following the government guidelines and all coming from our home offices. So fingers crossed, all of our technology works. However, we also have Neva and Jess from ARRB joining in for technology support. Next slide, please. Our presenters today are Tony Alosio, Director, Ecologiq, Michael Moffat, National Leader, Future Transport Infrastructure, ARRB, and Richard Yeo, Chief Operating Officer, ARRB. Next slide, please. Okay, let's get started, and we'll now be hearing from Tony.
Thanks very much. I'd like to give you a quick overview on Ecologiq and the Recycled First policy. I know that some people will have been to the earlier sessions and will have seen these slides before, but I think it's good to reiterate it, and for the new people, hopefully there's something meaningful in it. Thank you. Next slide. Okay, so Ecologiq, our role is to optimise the use of recycled and reused materials. We're using Victoria's Big Build as the vehicle to do that. And it is an important time for the Victorian government when it comes to recycled materials. We'd all be well aware that we can no longer export these materials off to China and other places. And we'd also know about lots of landfill crises that have occurred in the state over the last few years. So with this looming mountain of materials growing in waste stockpiles, we're looking for a way to use those. And Victoria's Big Build, which has a great appetite for materials, is the place where we can potentially turn that problem into a solution or into part of the solution. A lot of that means innovating. It means growing our domestic recycling capabilities. It means building local markets, and it means building new uses for recycled materials. And Ecologiq is working on all of those aspects and has strategies in place for those. I guess the key point for me is that we want to turn the use of recycled and reused materials from something that has been, I guess, opportunistic. It has been used and is used, but is somewhat ad hoc, somewhat opportunistic, into a more deliberate, intentional, uniform approach. And I think by doing so, create a new norm and a business as usual way of saying recycling is the way we will develop, deliver, and maintain our road and rail assets in Victoria. Next slide, please, Michael. So one way will be deliberate, and an approach to this sort of a way of making it uniform is the Recycled First policy. This is government policy released in about March of this year and starting to be enacted now, where we're requiring bidders on all major transport projects to demonstrate how they'll optimise recycled and reused materials. There's quite a bit involved in delivering that, including developing a Recycled First plan and a number of other initiatives inside that. And that will lead us towards the realisation of a circular economy through the greater use of those materials on those big build projects. We see that as then being leveraged to move into all of Victoria's road and rail assets across DOT and local government as well. And through that, creating this new norm or business as usual way of both delivering and maintaining assets. So with that, I'd like to hand over to Michael to carry on with the presentation. Thank you very much.
Thank you very much, Tony. Today we'd like to talk about demolition waste, and of all of the presentations in this webinar series, this is one that's probably talking about one of the most mature uses of material. Demolition waste has been used and permitted in Victorian Department of Transport roads for some time. So this is largely established practice. However, I think it's worth re-advertising the concept for those that aren't familiar, and patting ourselves a bit on the back, I think, too, for having taken things from opportunistic, as Tony said earlier, to routine practice. What is demolition waste? Well, the two primary ones that we're going to be talking about today are recycled crushed concrete and crushed brick. are the two most common ones. They usually come from construction projects or deconstruction projects, and sometimes from road pavements as well, although there aren't a lot of concrete and crushed brick or brick pavements in Victoria. In Australia, approximately 9 million tonnes of recycled concrete aggregate and just over 1.3 million tonnes of crushed brick are stockpiled annually. And these are engineering materials. They've been they've been constructed for an engineering purpose, and the reclaimed material can be reused for engineering purposes. Once it's reclaimed, the concrete and brick is crushed and stockpiled to a variety of grades and is treated again as a manufactured material, not a second-class citizen. The stockpiles are utilised across a range of common infrastructure applications, including road pavement formation and concrete pathways. We'll be spending a fair bit of time today talking about road pavements. Pretty much stands to reason that if it's good enough for a road pavement, then it's certainly fine for a pedestrian pathway. As I said earlier, crushed concrete and crushed brick are engineered products. The desired gradings can be produced in the production or the crushing of the material. It's a controlled process as much as it would be in any one of our quarries dealing with virgin aggregate. Crushed concrete and crushed brick is commonly used as an unbound material in our road construction. It can be used in bases for lightly trafficked roads. There are some concerns with crushed concrete re-cementing with time and causing reflection cracking, which tends to be a concern more in heavily trafficked roads, and therefore in the heavy traffic roads, the predominant use of crushed concrete is usually in sub-base material, including freeways. And there are heavy-duty motorways, freeways, arterial roads in Melbourne that have crushed concrete sub-bases. And by crushed concrete sub-base, I mean 100% of the sub-base is crushed concrete. Approximately 50,000 kilometres of the road network in Metro Melbourne has pavements that has bases or sub-bases that are constructed with cement-treated aggregates. And as you'll see later, those sub-bases in the heavy-duty roads tend to be re-cemented deliberately as part of the design concept. And crushed concrete can also be repurposed for use in pathways. I'd like to show you two different types of road pavement. These pretty much represent the extreme ends, I suppose, of the types of pavements that are typically constructed by the Department of Transport in Victoria. And in both of these pavements, there is a role for crushed recycled concrete to be substituted instead of using virgin aggregate. The pavement on the left is a very typical Victorian urban heavy-duty pavement. This is the sort of road that you'd see on a newly constructed freeway, or for that matter, an oldly constructed freeway. Hume, Monash, Eastlink. It's a thick asphalt pavement, typically a minimum of 175 millimetres of asphalt material. It sits on top of a cement-treated sub-base. Now that sub-base can be either virgin aggregate or it can be purely crushed recycled concrete. It's approximately 200 millimetres thick, and cement is added to form a bound material, so we expect it to be bound. So the re-cementing of the material isn't a problem there, it's desired, if anything. So that material can be 100% crushed recycled concrete. That sits on top of an unbound sub-base, which is also a working platform that the rest of the pavement can be constructed on top of. That can be either a Class 4 virgin aggregate or a Class 4 crushed recycled concrete. The Department of Transport specifications pretty much treat the materials as equivalent to each other. If we have a look at the pavement on the right-hand side, that represents a typical rural highway pavement away from the metropolitan areas. And that, instead of having an asphalt surface, has a sprayed seal surface, and the remainder of concrete of the pavement structure is unbound granular material. The base material is a crushed rock base. It could potentially be a crushed recycled concrete base, but only in a lightly trafficked road, which wouldn't be a rural highway. but in heavily trafficked roads like our rural highways, that recycled concrete can't be used in that environment due to cracking concerns. However, it can certainly be used in the upper subbase and the lowest subbase as a direct substitute for virgin aggregate. And you can see that's typically 300 odd millimetres of thickness plus of the pavement. So the bulk of the pavement thickness can actually be crushed recycled concrete. So you can see that the extremes of the VicRoads environment there, oh sorry, VicRoads, Department of Transport Victoria, sorry, I've had to die hard. There is a perfect use for crushed recycled concrete as a 100% replacement for virgin aggregates. We can also add crushed concrete and crushed brick as a supplementary material in our crushed rocks. So if the bulk of the material is a crushed rock, we can have components of that crushed rock material being crushed concrete and brick. And this table highlights the current Department of Transport Victoria guidelines. So the class 1 crushed rock that I spoke of earlier that couldn't contain, you couldn't use crushed concrete in it, you could actually have up to 5% of that material being crushed concrete if you so wished as a supplementary material. However, if you look midway through that table, you see class 3 crushed rock, source rock, that could be 100% crushed concrete. And that's the environment, that's the example I was talking about in the rural pavement. And you can see similarly, brick can be used in small percentages in class 1 material and in increasing percentages up to 50% of a class 4 material could be composed of crushed brick. So there's definitely a use for these engineering materials in our new road construction. One thing I do want to talk about is the difference between design inputs and performance outputs. This will become a little apparent as I go through. If we have a look at the different types of materials that we design our pavements with, we can see that there's a difference between how we characterize those in a design process and how we actually expect them to perform. When we're designing an unbound crushed rock or crushed concrete pavement material, the two design inputs that we're interested in as pavement designers are modulus, just Young's modulus for the civil engineers in the audience, and the California bearing ratio, the CBR. Both of those are indications of the stiffness of the material. From the pavement designer's point of view, that's all we care about is the stiffness of the material. The way that material will perform in the field, the main distress mode that we expect to see as the pavement nears the end of its service life is deformation of the material. And deformation is largely unconnected to stiffness. So our design input uses parameters to do with stiffness. Our distress is deformation. And there's absolutely very little link between the two. Similarly, for cement treated crushed rock or crushed concrete subbase materials, we're interested in modulus, the unconfined compressive strength, again, stiffness, strength, and we're interested in the development of fatigue cracking or crack resistance. Now, there are two modes of distress that we expect to see in these materials. There's deformation, which again is unconnected to the modulus, the unconfined compressive strength, and the fatigue performance. However, the cracking mode is directly related. We use the characteristics that we use in the design process for fatigue cracking have a direct bearing on the performance stress. But you can see for the majority of the performance, there's a complete disconnection from the pavement design process to how they perform in the field. And the way we get around that problem is through material specifications. The design method cannot act alone. It must act in concert with material specifications to achieve the desired outcome. And the details about material quality, how to achieve quality, what's permitted, what's not permitted, is all buried in detailed Department of Transport Victorian material specifications. The pavement design process just assumes that you will be using good quality material. The definition of what a good quality material is in those specifications. The two in concert will get you to achieve your desired performance. So on that end note, what I would like to do is pass over to my colleague Richard Yeo to actually talk about performance in the field with some case studies. Thank you.
Great, thanks very much, Michael and Tony. It's certainly my pleasure to present to the webinar today. Very interesting topic, use of demolition waste in transport infrastructure. Now, as Michael says, the question is, will these alternate materials perform with the recycled first policy? You know, we want to be sure that the products that we use to build our infrastructure will give us that long-term performance that we like, that we look to, and the public looks to in that public asset. Fortunately, there's a very strong evidence base for the performance of these materials, and just one example of that, and a very significant one, is the Western Ring Road, now known as the M80. This motorway was built to the west of Melbourne, the Ring Road, in the early 1990s, and it was the first design and construct of a major project in Victoria. That enabled the design and constructors to innovate and try some different things that weren't common at that time. In this case, they replaced the cement-treated subbase with recycled concrete aggregate as a cement-treated subbase in many of the sections. So how did that go? We've been driving on this road for a long time now, and fortunately, back in the day, sorry, next slide, ARRB was involved with doing long-term pavement performance monitoring studies, and I've just wanted to show you two sets of results for the Western Ring Road M80 pavement, the original pavement built in the early 1990s. In this slide, I show you the progression of roughness with time over about the first 10 years of this pavement's life. And the interesting thing, you'd all know that traffic on the Western Ring Road is very heavy. And in fact, because it was a new alignment, the traffic, design traffic was very difficult to estimate. So the best estimates were done for, let's say, a 30-year life, but in reality, what was happening, it attracted more traffic than what the design traffic was. And in fact, it exceeded its design traffic in the first 10 years of life. So this chart represents pretty much 10 years, but the whole design traffic for this pavement. Now, if you know about roughness and ride quality on new pavements, if you get less than 1 IRI, meters per kilometre, you're doing pretty well. And you can see here at the start, this pavement was built to a high standard with a very smooth ride quality, less than 1. However, you look across the 10 years and the whole design life, and it stays pretty constant. So the pavement, which is a heavy-duty asphalt on cement-treated pavement on the Western Ring Road, the original pavement has performed very well during its entire design traffic. And of course, around that time, it was actually upgraded and widened to cater for that additional traffic. So it's a good life cycle picture of how this pavement performed. We move to the next slide. The next slide shows the stiffness of the pavement. Now, Michael Moffat mentioned the importance of stiffness in a pavement design and in its performance. In this case, we're measuring stiffness using a falling weight deflectometer and measuring the deflection of the pavement. And the graph shows the progression of deflection over the first 10 years life prior to the upgrade of the M80 and the widening. The data shows a deflection, maximum deflection of 100 microns or 0.1 of a millimetre. And it's, apart from that odd data set just around 2000, the data shows a very stiff pavement for the whole life. And again, that is representative of a very good performance of this pavement with recycled concrete aggregate as a subbase over the design life. Next slide, thanks. So let's have a bit of a chat about some barriers and opportunities to using demolition materials in our road transport infrastructure. Next slide, thanks. So some of the considerations are listed on this slide, and as Michael said, we're really trying to develop engineered products using recycled materials, and these involve quite detailed material specifications and, of course, construction quality. So one of the barriers is potential for contaminants in these aggregates, and as Tony mentioned before, if we manage our stockpiles of recycled materials to the highest degree, we can avoid, I think, the costs of mismanagement of stockpiles around over $163 million. So contaminants are a key issue. One of the ones in recycled crushed concrete that we're quite good at managing is asbestos contamination. And in fact, while Victoria's been using recycled concrete aggregate for maybe 30 years, Western Australia Main Roads Department is only just allowing it, and they were too concerned about contaminants. So that can be a barrier. As I said, it's an engineered material, and we need to meet specifications and have good construction quality. So trial batches are important to understand how this material mixes and how it goes down. As Michael Moffat mentioned, blending of recycled aggregates with natural aggregates is a good thing, and there's specifications around that and limits on what can be done. And good practice is to pre-wet these aggregates due to their high absorption rate. So when you're determining your optimum moisture content for compaction, you need to take that into account. And it's suggested that we avoid the fines because these might reduce workability, strength, and finish. Next slide, thanks. So as I said, improving stockpiling techniques, managing where the aggregates or material comes from, which demolition site, and managed keeping the good stuff together and maybe separating out the not so good stuff or the undesirable materials will lead to its highest best use. So stockpile management is very important, and using trials to test the materials. The other area that I'd like to talk about is specialised testing, because as I said, we've got a good evidence base on how these materials perform, and we've been seeking to link their performance back into the laboratory and develop specialised tests that are very good indicators of their performance. Next slide, thanks. In terms of specialised testing, I'd like to talk about two areas. As Michael Moffat said, one application is use of demolition waste as an unbound granular material. And in that case, the performance is related to deformation or rutting of the pavement. Now, we do have a laboratory test, a large format wheel tracker test, that can give us a very good indication of the rutting or deformation performance of various materials in the field. Next slide, thanks. So this test was developed with some very rigorous national research over many years, and the laboratory test was validated against full-scale performance using the accelerated loading facility. This slide shows a couple of examples of the way the test results are reported, and they're reported in terms of the deformation or rutting on the Y scale against the number of load cycles. So you can imagine a rolling wheel load applying up to 40,000 loads, and quite a heavy load as well, representative of a truck load or an axle load, and then the development of rutting in the material. And it's quite a large sample. As I said, it's a large format wheel tracker test. So on the left, we have a class 3 subbase recycled crushed concrete as an unbound material. And you can see that the rutting in this test is about, on the bottom line there, about 3 millimeters at the end of 40,000 cycles, but its performance is quite consistent. Initial development of deformation, and then it sort of plateaus out. On the right, we have a lower class or class 4 recycled crushed aggregate with 20% brick and 20% glass added. This test enables us to trial different combinations of recycled materials and see how they perform and what the limits of performance might be. In this case, we've got different additives or brick and glass added with the aggregate, and the rutting is slightly higher. So it's around 4.5, 5 millimeters after 40,000 load cycles. Through this test, we can trial, as I said, any type of combination and gain confidence in how that material might perform relative to either a pure recycled crushed aggregate or a virgin crushed rock. So if we've got a good history on a crushed rock that we know works, we can see how our alternate materials and pavements will perform in deformation using this specialised test. Next slide, thanks. So as we said earlier, in design, a cemented subbase or a bound material might be the application for the recycled aggregate, and we need to understand the properties of that cemented material. The newer specialised testing we can do is a 4-point bending flexural beam test. This enables us to measure not only the crushing, well, normally we'd measure just crushing strength, as in unconfined compressive strength, UCS. This new test enables us to measure the flexural strength of this cemented material It also enables us to look at the modulus, flexural modulus, and that's a design input, as well as the fatigue performance. So in this case on the left, you see the test rig. It's quite a professional test rig these days, and 4-point bending. So the beams are a 100mm square cross section. They weigh about 10 kilograms each, and we usually cure them for about 90 days to get a representation of their long-term life. And on the right, I've got some example results for flexural modulus represented in gigapascals, or you could say megapascals. Often in Victoria, a cemented subbase is designed as a working platform with a 500 MPa modulus, or a 0.5 gigapascal modulus that's shown in the red dashed line. And the chart shows the results for a recycled crushed concrete aggregate in the middle, which is about less than 10,000 MPa, 10 gigapascals, and how it relates relative to a range of other virgin materials. And you can see they're right up there in terms of flexural modulus, and certainly well exceed a design modulus of 0.5 gigapascals. So quite applicable to use, and hence we can see the good performance as I showed earlier on the Western Ring Road over many decades. Next slide, thanks. So let's look at a couple of more recent case studies or current case studies, and the first is the Mordialloc Freeway. Next slide, thanks. So this is a new 9-kilometre motorway that will link Mornington Peninsula to the Dingley Bypass. And there's been a whole lot of use of recycled materials. As Tony mentioned, this is now policy. So 100,000 tonnes of crushed concrete in the subbase, so that's very good. And another 400,000 tonnes of crushed concrete in road drainage applications on the job. And certainly there's potential for more use as the project progresses. And I'm very much aware that they're using a recycled or reclaimed asphalt pavement quite strongly in this construction job. So it's also the first to use the new road-based product, which includes glass and crushed brick, as I mentioned before, that you can have any number of combinations, and you can test the engineering properties of these prior to use. And lots of other sustainability measures on this project, including recycled water and renewable energy sources. Next slide, thanks. So another one is the Caulfield to Dandenong level crossing removal project. Next slide, thanks. So often on these jobs, there's the need for temporary works. In this case, there was a precast concrete yard needed to be established, and this to produce more than 2,200 precast concrete segments for the Skyway, for the rail line, elevated rail line. So for these temporary works, more than 17,000 tonnes of recycled concrete were used in the foundation, and also a specified mix for the precast concrete segments included 21% cement replacement through the use of fly ash, another recycled waste product. So again, a range of energy saving initiatives were also implemented, and the precasting facility operated 24/7. So use of rainwater tanks, LED lighting, renewable energy sources were adopted. So these are really good case studies of where we can use demolition waste, and we can save on energy, we can recycle water, etc. Lots of opportunities for this, and as I said, it's all about engineering properties, management of stockpiles, specifications, good construction quality. We can get really good outcomes from using demolition waste in construction of our new infrastructure. Okay, I might finish there. Thank you very much. Next slide.
Perfect, thank you all. We have a question that's come through from Joanna, and they have asked if you can explain the difference between the different classes of recycled concrete. Oh, Mike, I think you're self-muted, so you might just have to unmute yourself. There we go.
Now I'm unmuted. I think we may have double muted me there. It's the actual answer is it's more to do with the different classes of crushed rock, the virgin material that the crushed concrete can be used as a substitute for. There are different grading requirements, and by grading we mean the different particle sizes that make up the crushed material, from very fine material up to say 20mm size coarse rock. Crushed recycle and the different classes of material for crushed rock will have different sorts of levels of performance. Like a class 1 material differs from a class 2 material in that it has what we call some plasticity in the fines. It means the small fine component of the crushed rock material has a bit of clay in it, and that makes it easier to work with, which means that you get a smoother ride quality. So class 1 type material will give you a smoother ride. Now, the recycled concrete terms we were seeing earlier was to do with using crushed concrete aggregate in place of virgin quarry aggregate in those different classes of crushed rock material. So it's not so much that the quality of the concrete is changing, it's the quality of the class of material that it's substituting for. I hope that answers the question.
Perfect. Thanks, Mike. So we don't have any other questions at the moment, but everybody attending, now's the time to send them through. We'd love to have a discussion with you all. We actually have a few popped in just now, so perfect. We have a question from Mangisha, and they have asked, do you use RCAs as aggregate, either blending with virgin aggregate or by itself?
It can be used as a blend with virgin aggregate in sub-base materials. The Department of Transport in Victoria would only allow a small amount of the recycled concrete aggregate to be blended into a base class material due to re-cementing concerns, but it can be 100% or any percentage less than that in sub-base material. From recollection, I think the table I showed earlier showed up to 5% of recycled crushed concrete aggregate could be used in a base course material as a supplementary material. Again, I hope that answers the question.
Thank you. We've had a question come through from Andrew, and they have asked, do any contractors resist the uptake of granular materials incorporating demolition waste with regards to variability and constructability?
I'm sorry, your voice broke up a bit. Could you repeat the question, Isabel?
Sorry about that, no worries. So Andrew has asked, do any contractors resist the uptake of granular materials incorporating demolition waste with regards to variability in constructability?
I don't know, to be honest, whether they do. I know that they should have no concerns with regard to variability. The materials are managed through stockpile management that both Tony and Richard have spoken about. So there shouldn't be any variability concerns. The material can be a little bit more difficult to work with. It's a bit bony and drier. However, pre-wetting of the aggregate should alleviate those concerns. So I don't believe there are real barriers for stopping contractors from using the materials. Whether or not they perceive there to be barriers or not is very much a matter for themselves, though. Tony, do you want to make a comment in there?
Yeah, well, perhaps I will. Just generally speaking, I think you sort of said at the start that these are well-established products. I think the proof of the pudding, has been in the eating. Crushed concrete in particular is a really popular product where it's available. Within the Westgate Tunnel and a number of other high-profile projects take it on and use it. And I think because of the experience and the time that it's been used, the sort of constructability issues and the consistency issues that are have all been sorted out either by specification or by construction techniques over a long period of time, as opposed to perhaps the more emerging products where people are like plastics and asphalt or whatever, where people are a little less sure of outcomes yet because they're more emerging. So I think the experience is it's a good thing. There still may be pockets of resistance or pockets of people who are unsure. Hopefully these sorts of master classes help relieve some of those concerns if they still exist.
Thanks, Tony. We've got a question from Samuel, and they have asked a question regarding recycled crushed concrete for use as class 3 on reactive soils. How can you guarantee the residual cement content percentage appropriate and won't result in reflective cracking?
So I think it's certainly an interesting topic around Melbourne, particularly around the west. Reactive subgrades need to be managed. And I think there's two separate issues here. Reflective cracking from reactive subgrades is going to occur regardless of what pavement you put on top. You can put a concrete pavement on top, and if the reactive clays and the drainage and moisture change is not managed, that will swell and that will cause cracking. So I think there's one topic is managing reactive clays, and you know, there's lots of good information around how you do that, and compaction and the moisture content, equilibrium moisture content, and minimising moisture changes are the key there. And there's, as I say, good guidance on that. In terms of self-cementing or re-cementing of base course recycled concrete aggregates, that has been experienced if it's used as a base. Hence, the base course specifications from the DOT limit how much recycled aggregate, 5 or 10% typically, and that will avoid the problem. If you use 100% recycled concrete aggregate, depending on where it came from and the original concrete, it's likely to re-cement and shrink, and that's where you get cracking. And it depends on what you put on top of that. So if you use it as a sub-base and you put a granular base on top of it, you're fine. Hence, you can use 100% in a sub-base, but not in a base. But I think there's two issues there to cover. Thanks.
Thanks, Richard. We've got a question come through from Alan, and they have asked, have any issues arisen regarding the health effects related to concrete and brick dust in the production of the crushed waste product, such as silicosis?
Look, well, perhaps I'll jump in for a minute. You know, silicosis is you know, it's again a serious health issue that you know, is widespread across, or widespread concern across a range of industries. I think it's been behoving on the industry and on the regulatory authorities to understand how to manage silicosis. So that's been done to a great extent. I know, you know, from personal experience inside quarries and inside production facilities that there's been a lot of testing, but also a lot of management plans that actually work through those types of issues. You know, some quarry materials have no silica in them. Some quarry materials have high percentages of silica in them, depending on the nature of the rock in a virgin material aspect. Similarly, you know, we have these other products, these other recycled products that are available to us. We know that the issue of silicosis is a risk, and there are management processes and controls that I know are in place from reputable suppliers to be able to manage that. It's a really good question and a really good thing to highlight that you know, whatever recycled materials we're talking about, human health and safety is no different to whether or the need for human health and safety and the control of human health and safety is no different for a recycled product as it is for a virgin product. Those requirements and needs to manage those things, to understand them and manage them and ensure that that there's no detrimental effects on people, need to be understood, and it's the same criteria. There's no get out of jail clause because you're doing a good thing by recycling. You know, the first and foremost approach is for human health and safety, and so all of those regulatory and moral issues apply to both government and suppliers and users. That's sort of a bit philosophical at the end, but there are practical measures in place that I'm aware of from the suppliers I've dealt with in the past to manage those issues.
Fantastic. Thank you, Tony. We've got a question from Megan, and they have asked, are there any combination of demolition waste that have not been used as yet, i.e. Mordi and their glass/brick?
Brick is being used as a supplementary material, and glass, I think I'll leave that to Tony.
Oh, okay. So, you know, glass recycling, I think was a subject of one of our earlier masterclasses. It's a growing area, an emerging area, and it can be used in a range of activities on construction sites. And I think people are still exploring the opportunities there. And there's a heck of a lot going on with glass, as probably everyone's aware, in terms of curbside recycling, container deposit schemes, and a whole raft of things. But glass in construction is certainly an option, and it has been used at Mordialloc. I think, you know, there are other products. They might not be construction and demolition waste per se, or they may be, but there are slag aggregates, and there are, you know, we heard about fly ashes and the like. So depending on where you want to stop and start the definition of what is a demolition waste versus some other type of waste, I think the opportunities are still there. I think Mordialloc is, though, and I will say this, Mordialloc is an exemplar of how to take the philosophies that I spoke about at the very start, about recycle first and about making that business as usual, and actually thinking about how to do that as a first priority rather than as an opportunistic thing. It is a perfect example of where to go and say, that's about best practice for now. There will be more best practice. There'll be better things coming still. And Mordialloc still got a few other surprises or a few other benefits still to come. But, you know, there are a raft of other recycled products that I think that are emerging and that can still be considered. You know, go to Mordi and have a look at what's best practice by all means, and then see how you can do better, I think, is the next is the answer to that.
Thanks, Tony. We've had another question come through from Mangisha, and they have asked, have you ever used RCAs in a concrete pavement? If so, what is the percentage?
I can't give you a percentage, but I can say yes, they have been used in concrete pavements in Australia and in other parts of the world. I was talking to a colleague of mine in Austria a while ago, and he was describing them replacing a continuously reinforced concrete pavement that essentially went from one side of the country to another. Now, admittedly, it's not a very wide country. They replaced the entire pavement with the material from the old pavement. They took the aggregate, blended in some new stuff when they needed extra levels, but they essentially made a new concrete pavement out of the old concrete pavement. They put in new steel, to be honest, but they progressively built staging plants across the country, and as the road extended, they just were pulling up old pavement, crushing it and mixing it into a new batch plant and spinning it down. So it's very, very doable. And that was done partly with a view to sustainability, but was also, quite frankly, cheaper.
Perfect.
Very
Thank
doable.
you, Mike. We've got a question come through from Javad, and they have asked, hello, and thank you for the very interesting presentation. Are there any risks of heavy metal from crushed concrete, especially when used in road drainage?
No, because whilst there may be that material when it's pulled out of the construction site that it was demolished from, it is managed at a recycling facility. Materials like that are stripped out, and tests are conducted to make sure that there aren't contaminants and the like. And that's part of that stockpiling process that all three of us, I think, have mentioned. If Tony forgives me, I'll get a bit philosophical too. We are dealing with a material that we should see as an engineering material. We shouldn't see it as waste. It may come into the facility as waste, but as soon as it's in the recycling facility, now all of the engineering controls that you do with any other material kick in to make sure that you're producing a consistent, viable, uncontaminated material that can be used with trust and faith by the construction community.
Perfect. Thanks, Mike. We currently don't have any more questions that have come through. Actually, sorry, I'm wrong. One just slipped in then from Brendan, and they have asked, would you please send the project slides out to all participants, please? So I can answer this one on your behalf, guys. So Brendan, the presentation will be sent to everybody once we conclude. So you'll get that by COB today. Perfect.
Good
So in the
answers.
meantime, while there's no other questions, I think we will wrap it up. So thank you to our presenters today, and also thanks to the audience for tuning in. We hope you enjoyed these masterclass sessions, as this is our last one, and we look forward to speaking to you all again in the near future. Enjoy your afternoon.
Thanks very much. Thank you.
Thanks, everyone.
Thank you.